Thank you for joining another IoT Central workshop. Please ask any questions that you may have in the chat. We'll get back to you with any questions that are unanswered via the email address that you registered with. Hi, my name is Jenny Plunkett, and I'm a Senior Developer Relations Engineer at Edge Impulse. In today's video, I'm going to show you how you can create a non-human voice audio classification system with Edge Impulse to identify when a faucet is leaking. This demo can also be adapted for industrial use cases, such as identifying machine failures with grinding sounds, or even for wildlife conservation purposes to recognize the vocalizations of various endangered species in the wild. Edge Impulse is the world's leading embedded machine learning platform. The Edge Impulse Studio covers the full end-to-end machine learning pipeline to accomplish a variety of ML tasks from regression to vibration and sound classification to object detection and even predictive maintenance. You can import data from any sensor and deploy your model to almost any device. You also maintain control of all your data from the very beginning to the very end, and also all of the firmware that you deploy to your device. All code in the Edge Impulse Studio is also open source and available for you to use to deploy to your devices in production today. The Edge Impulse Studio covers the entire embedded machine learning pipeline, from collecting and labeling your sensor data, performing any digital signal pre-processing, training your machine learning model or your impulse, and finally, testing your model on real-life data and deploying back down to your edge device. The studio also guides you through the process of creating a precompiled firmware or library that will run your machine learning model on any number of platforms. The library output contains all of your pre-processing code, trained neural network, and anomaly detection code that you may have added so you can perform inferencing locally on your computer, on your edge device, or on your embedded device without having an internet connection. Before we get started, I'd just like to mention that all of our documentation for Edge Impulse and our various tutorials that we are showing in the IoT Central MicroSessions is available on our documentation website at docs.edgeimpulse.com. This website is especially useful if you're brand new to embedded machine learning or if you're brand new to embedded devices in general. Please check it out at docs.edgeimpulse.com. In today's non-human audio classification tutorial, we'll be following the exact same tutorial that we already have in our documentation called Recognize Sounds from Audio. You can find this at docs.edgeimpulse.com/docs/audio classification. To follow along with today's workshop, please go to edgeimpulse.com and create an account by clicking on the Get Started button in the top right corner. Once you've created an Edge Impulse account, you'll navigate to the dashboard by going to studio.edgeimpulse.com, and then you'll see the Select Projects page. This page contains all of the embedded machine learning projects that you're working on. As you can see, I already have a few available here, and I've already created one for the running faucet today, but you need to start your own project by going to the top here and clicking on Create New Project. Once you've created your running faucet project in the Edge Impulse Studio Select Projects page, this is where you'll be redirected to. So to get started with our machine learning project, and in order to accomplish the task that we'd like to do with embedded machine learning today, we're going to connect our device. So in order to record our data today of when our faucet sink is running and the background noise of our home, we're going to go to the Devices tab and connect our mobile phone. As you can see, I've already connected another embedded device here, and you can read all about the documentation in order to connect your own embedded device to collect machine learning data and sensor data at docs.edgeimpulse.com. But today, in order to make it simple, I'm going to connect my phone to connect to the audio microphone on my phone and directly pull sensor data from there through the web browser and upload to my project. So I'm going to click Connect New Device, and then click on Use Your Mobile Phone, click on Show QR Code. Once it's created the QR code, you're going to grab your mobile phone, open up the camera on your phone and scan the QR code as you would at any restaurant. And now I am successfully connected to my Edge Impulse project. As you can see, it says device is now connected. So then I'm just going to click Get Started, and it's going to take me to the data acquisition page. From the data acquisition page, I can see all of the data that I already have uploaded. In your case, if you're starting a brand new project, you won't see any data here, but you'll see data for both your training data and your test data for your machine learning project. In order to get a good model to identify when a faucet sink is running and when it is not running, we'll need to collect about 15 minutes of data in order to make this model, and we'll need to have about an 80-20 training and testing split. So in order to make our model, we'll need two distinct classes of data. We'll need samples that we take of just our sync running, and then we'll also need a noise class where we're taking samples of the background noise of our home. This is important because the machine learning model needs to understand what the data will appear to be when the sync is running and when it's not running. So in order to collect new data from my mobile phone, I'm going to scroll up and under record new data, I'm going to select my phone. And then under label, that's where I'm going to type in the name of the class that I'm going to start recording data for. In this case, I'm going to type noise, and I'm going to set my sample length to 30,000 milliseconds. And I'm going to select my microphone sensor, but Edge Impulse is great because you can also record data from the accelerometer sensor, camera sensor, and even the positional sensor on your phone and directly upload those to your Edge Impulse project. Just set my secret frequency here to 16,000 hertz, and then I'm going to click Start Sampling. So it's waiting to start. It may ask for permission required on your phone, so I'll give access to the microphone by clicking Allow, and then it will start recording data. So this will just be background noise, and we can continue to talk. But we have about 20 seconds left, and then we'll see a new noise sample pop up in our project. We can also see what previous types of data that we have uploaded and at what frequency by clicking on this Show Expanded View button. Once that's done sampling, it will pop up. And now I have a brand new noise sample uploaded into my training data set in Edge Impulse. So we're going to continue this process by changing the label of our sample that we're going to record on our phone to either noise or faucet. And I've already uploaded all of my faucet and noise samples, but you can also preview what all of these samples sound like by scrolling down the page and clicking on the play button underneath the sample raw data. So that's my noise sample that I just sampled. And here's a recording of my sink faucet. And this is super simple with your mobile phone. You can just take your phone over to your sink and click Start Sampling. So continue doing this for both your training data and your test data set. You want to get about an 80-20% split of how much data you have in your training data set and in your testing data set. If you put all of your examples into your training data set, you can go to the dashboard, scroll down, and click on the button at the very bottom, Perform Train/Test Split. And this will rebalance your training and testing sets to be an 80-20% split. If you'd like to download the same data set that I use in order to create my initial project, you can go to the documentation and scroll down at the very far left. We have a few pre-built data sets available for you to upload, and one of them is called Running Faucet. Just download the faucet data set, and you can upload the training and testing data via the Edge Impulse Studio's web UI or via the Edge Impulse CLI command line. Now that I have performed my training and testing split, if needed, I'm going to go back to data acquisition, make sure everything looks good, make sure I have training and testing data uploaded for both of my classes, noise and faucet. Then I'm going to go into the impulse design, and this is the graphical representation of how we're going to design and train our machine learning model. And this machine learning model in Edge Impulse is called an impulse. So the left block here, the red block, is where our raw data is going to be initially brought in. So this is our time series data for our audio classes, noise, and faucet. The window increase is just how many times we're going to step over the sample to do our signal pre-processing. And since all of our samples are at 16,000 hertz, we don't need to do any downsampling or upsampling. But of course, if you do have samples of audio data that are recorded at different frequencies, you can downsample or upsample that here. So I'm going to add a processing block, and there's a bunch of processing blocks also available for you to use by default with an Edge Impulse. And these are just Python snippets or code snippets that are wrapped around in a web GUI. So today, because we're doing non-human voice audio, we're going to select the audio MFE block. If you'd like to do your own signal processing, you can scroll down and click on the raw data block. Also, all of the code that we use for these digital signal pre-processing blocks that are default within Edge Impulse are available on our GitHub repo. If you also know how to write your own signal processing code, you can also host your own custom signal processing block using the Edge Impulse Enterprise Organization features and by adding your own custom block following the instructions that you can view here. So I've added my MFE block. I'm also going to add a learning block, and today we're going to do classification because I want my machine learning model to recognize when my faucet sink is running and when it is not running. So when there's noise in the background and when there's actually the sinks running. So I'm going to click add. And so now I have my entire machine learning pipeline from my raw data into my signal pre-processing, extracting those features, pushing those extracted features into training my model, and then finally getting those output features from the trained model and doing my inferencing. So I'm going to click Save Impulse and then move on to our digital signal preprocessing block, or our MFE block. You're just going to click MFE. And because this is a pretty simple use case, we're only going to want to find the difference between faucet and noise. We can view what our default block in Edge Impulse will output in the spectrogram format for us. So we can see our raw features, and these are just the integer values of the audio data that we have uploaded. And then we can also see the spectrogram visual output of what our data will look like after it's been processed through our spectrogram filter. On the bottom right here, we can also see the on-device performance of this MFE block that it will have on our Edge device. And in this case, we're estimating performance for a Cortex M4F 80 megahertz embedded device. So it takes about 359 milliseconds to process this data to get this DSP result and 41 kilobytes of RAM. So I'm just going to go down to the bottom and click on Save Parameters. And this will take us to our Generate Features tab. From this tab, you're just going to click on Generate Features and you'll start to get this feature generation output. And if you previously generated features on another version of your dataset that you've uploaded, you may already see a Feature Explorer. But this Feature Explorer will update every single time you upload new data and do re-extraction of your features. So now that I have successfully extracted my features, I get this great little visualization of what all of my training set samples look like when they've been uploaded and been processed through my MFE block. And this is just a 3D visualization that is generated from the UMAP algorithm, and you can read more about that on our documentation site. But you can click on each individual sample and zoom in and out and see where these samples lie within the 3D field. So you can see here the blue ones are faucet classes and the orange are noise classes. You can click on each individual one and see exactly which window of which sample this point on this graph came from. So this one was noise and this is faucet. So I can already see I have a great separation of my data, which means that my machine learning model will likely perform really well. But if this Feature Explorer looks like a big jumble, messy bit of points in a cloud, it doesn't necessarily mean that your machine learning model is going to perform badly. It just means that your machine learning model needs a bit more compute in order to train, in order to recognize those patterns in your data set. So our model is looking good, and we haven't even done the machine learning model training yet. So on the sidebar, click on Neural Network Classifier. And we're just going to leave these defaults, but this is the, again, graphical representation of the code that you would have normally written with TensorFlow and Keras. So we have our number of training cycles here, the learning rate, the validation set size, and the neural network architecture and other data augmentation options. And I'm just going to leave this default because we're doing this really simple today. But if you know how to write your own Python code in TensorFlow, you can always switch into Keras or expert mode by clicking on the 3 buttons here at the top. Click on Switch to Keras mode, and you can see exactly what this code looks like in the TensorFlow Python script. So I'm going to switch back into simple mode. I'm going to scroll down to the bottom. Can see all of the various neural network architecture layers that I have here. I can also add other layers that we already have pre-written for you in Edge Impulse. And then I'm going to click Start Training. What this is doing is it's taking the extracted features that I got from my MFB block and training a model based on this new information. And all of this training is done in the cloud. And once I then deploy this model to my Edge device, I'm just taking this output of this trained model, all of the numbers that come out of this from this mathematical operations, and putting these mathematical operations in order to classify my new audio data on the device. So no training on the device, no more connection to the internet. I'm just using the model that I resulted from this deployment tab that I'll then show you in a few moments. So we're going to wait for this training to finish, and then we'll move on to live classification and testing our model. So now that our model has finished training, we can scroll down and see the training performance, accuracy, output, and confusion matrix. So our model is really accurate, which we could have guessed from our DSP block page, our generated features. But we can see exactly which of our samples were correctly classified and which were incorrectly classified. If you zoom in here really close, you can see exactly which red and green dots on this 3D visualization were labeled correctly by the trained machine learning model based on our validation set. So I can again still click on each individual sample and see if it was correctly predicted to be the right class, either faucet or noise. And then I can see my on-device performance for my device. In this case, we're predicting for Cortex M4F. And it's going to take 2 milliseconds to get from the extracted features into predicted inference result, either noise or faucet. It's going to take 11K of RAM and 35K of flash. So it's a pretty small model for an audio use case, and it's great for embedded applications. So now that we've trained our model, we can directly test that our model will work in our real life setting by going to the model testing tab or the live classification tab. If we're going to do the live classification tab, we first need to make sure that our phone is connected. If you're using your mobile phone to collect new data, as we did earlier, you can just go to your web browser and refresh the page, and it should reconnect to your project successfully. Connected. So I'm going to scroll back down to live classification and take a brand new noise sample and have it be classified directly by my model that we just trained in our Edge Impulse project. So I'm just going to take 10 seconds or 10,000 milliseconds of data here at 16,000 hertz and click Start Sampling. Again, this trained model has no idea what the expected output should be, so we're just going to see what it predicts for us. And I need to give access to my phone's microphone, and it will start. Great, so my phone just successfully took 10 seconds of new data, and this was noise data, as we know as humans, but we did not provide any expected output to the Edge Impulse Studio. So the expected outcome in this case is labeled as testing. And as we can see here, for every single window of our sample, it was successfully classified as noise. So our model was working really well in our real life environment using the microphone on our mobile phone. I'm also going to go ahead and test this by recording a new sample of my faucet. I'm going to click Start Sampling and go over to my sink. This one might be interesting because I have my cats in the background, and I'm not sure if any noise samples that I'm uploading included their little meows. So great, it successfully classified the majority of my sample as faucet and only a few as noise. But we can directly go look at those and see what it sounds like at that part of the sample by finding the result where it classified as noise. I think it's just at the top here. So we can play our sample and see what that sounds like. It looks like it got the entire sample correct, even though my cats were meowing in the background. This trained model is going to perform very well in our real-life environment. So now we're almost ready to deploy our model. We can also go down to the model testing tab and bulk classify our trained model against our entire test set. Just go to model testing and click classify all. Once the model testing tab has finished bulk classifying all of our test data, we can see the expected outcome and the classified result on this field here. We can also see the percentage of all of our test samples which were correctly classified and which were labeled as testing because we, the human, did not manually label the expected outcome for these samples. We can see the feature explorer and where the windows of these samples in this 3D visualization came from exactly and what they sound like. And now we'll go on to the deployment tab. Now from the deployment tab is where you can see all the options on how you want to deploy your trained model onto your edge device. So under create libraries, where you'll see all the options you'll want to select if you have a board that you want to deploy your model to that is not officially supported. Official support is just all of the options that we have in Edge Impulse for creating proof of concept pre-built binaries. And these are binaries that come with all of the code that you need wrapped up in order to directly drag and drop a firmware onto your board without having to write any code. So today we're going to do our mobile phone deployment, but you can also easily create a C++ library or Arduino library for any device that you don't see on this list here and you have microphone driver support for. You just compile a C++ library into your embedded application just as you would any other C++ embedded project. There are no external dependencies, and it can be compiled with any modern C++ compiler. So today I'm going to go down and I'm actually going to select the mobile phone option here at the bottom to run our impulse directly on our phone. This takes our trained model, builds it, and allows us to run the model through the web browser on our phone using the WebAssembly library. So I'm going to scan the QR code with my phone, just as I did when we did a data collection earlier. It's going to build the project in the web browser on my phone, but again, this trained model that we're building and deploying is not connecting to the internet. We're only getting the trained mathematical parameters that we have gathered from the Edge Impulse Studio to run on the device. So I'm allowing my microphone to have access. You can see here that I'm doing live audio classification of faucet versus sync audio data on my mobile phone directly from the mobile phone deployment option from the Edge Impulse Studio. So there's faucet and noise being calculated here. Sometimes it also misclassifies, and this just means we need to upload more data to our training data set so our model becomes more accurate for the environment we'll be using this model for. And that's it. We're now running our audio classification for noise versus sync audio data directly on our edge device, in this case, our mobile phone, on the edge, no connection to internet, doing all of this classification of our new and incoming audio data directly in the web browser on my phone. And that is Edge Impulse audio classification for non-human voice applications. Thank you, IoT Central, for hosting this workshop. You can find more Edge Impulse MicroSessions at iotcentral.io, where this video will also be available on demand. If you have any questions about Edge Impulse, please post a question on our forum at forum.edgeimpulse.com. And we'd also love to see what you build, so please show us that as well in our forum at forum.edgeimpulse.com. Thank you.